All right, welcome to our presentation from the team from Noord-Holland, Better Wet from Sweat. I want to say kiitos to the organization for this very interesting challenge, opportunity to go to wonderful Helsinki and to see some wonderful other presentations. And also kiitos especially for taking us far, far from our comfort zone, which is always good. But unpleasant. The team. Bas, our fearless leader, he said, there's some challenge I want to do. Are there people who want to participate? We are all public servants at the province of Noord-Holland. We do GIS, but we are, I will not stress this another time, but we're not like a hip development team or something like that. We do asset management, infrastructure. We use FME and Python. We do stuff like that. We think of data models to the quality of the roads, where they are. We send them to contractors, we get them back. National registries, we do stuff like that. So we do a lot of things with data, but it's usually data we are the boss of. So not strange data, not Inspire-like data sets. Which we have to use and which have different rules. The team, we people who wanted to participate are Jelle, he's the part-time musical star, part-time GIS specialist. He made the movie yesterday. Cindy, she was responsible for making the services and came up with the idea to use Bootstrap to make the app look a bit more nice, and Sander is our back-end FME developer. And he thought of ways to make the moving cyclist interact with the clouds and do the routing and timing.
So actually not interact, but
no, in data. Yes. This is me on a recumbent bike. Actually a better bike than the normal ones, but they're not very popular. But in the Netherlands they're very good because the wind is not too. The wind is not as strong because you're a little bit lower. Apparently, I said something about that. The nature of the data we use usually is of the asphalt and where we are riding. And this was an interesting challenge, but now we had to deal with the data of the weather, precipitation, forecast, which was very more dynamic than what we're used to, because asphalt is very slow and predictable, and the weather is not. So, and this is our fearless leader, Bas, on a mountain somewhere in very, very dry conditions in Canada, I think.
Obviously, we need some route planners because if you get stuck like this on the slope...
That's true. The challenge, again, this is what we want to prevent. We prefer to get wet from our own precipitation, our sweat, and not from hailstorms and rain falling on our heads. So, no more of this. Very quickly, this is how our app would look like. I have a route, I want to go somewhere with my bike. I say I want to go to that place. I start here. A route is planned, and it's planned around precipitation, which is provided by a data provider, a National Meteorological Institute. Okay. Possible.
Have just one back look.
Sure.
Have a look at the clouds, notice them, because we're going to do a demo in a few minutes time, and at the moment it's not so rainy in the Netherlands. So we hope to find some clouds in the southeast to have a good demo of our province. But otherwise you can see here from how the route goes around the rain.
Mm-hmm. Sure.
When developing this app, one of the first considerations that came up was like okay, we want to make cycling routes, plan cycling routes that make a detour for rain clouds, but what kind of route network do we use? First we thought of OpenStreetMap, because this is a really good map, even has indications for cycling paths in it. So it was very nice to use. But one problem with OpenStreetMap was that it knows all the cycling paths in the Netherlands. And there are so many. And there are so many intersections. You could easily, in a few seconds, have one intersection, cycle a few meters, and then go in another direction on the next intersection. And a cycle route planner, like we wanted to develop, has to take into account this rain data, which usually comes as grid data, rasters, that need to be processed. And well, everyone familiar with raster processing knows this may take some time.
Yes, and the route has to be permanently updated. That would be best, because weather conditions change all the time.
Yeah.
So you cannot plan a route one time, you have to plan it all the time.
Exactly. So if you have to switch on every intersection, there wouldn't be enough time for all the raster computations to take place before you worry about it at the next intersection. So then we thought, like, well, we have another kind of network in the Netherlands that's called the fietsknooppunten network, especially for cycling, especially recreationally very interesting, that have signposted markers outside, and you can actually just follow follow their numbers to have a very interesting route through the Netherlands. And there are many, they're everywhere in the Netherlands. We implemented this route planner just for our province, just to keep things for pilot demonstration usages quite overseeable.
Yes.
Sorry, quick. I'll just check your
En Gijzentijnmuziek. Yep.
So that was the network that was, for this reason, very good to use. And of course, one other consideration was that the network needed to be dense enough in terms of path density to be able to avoid the clouds. So you have to be able to make a turn to the right if rain comes from the left. And for the cyclists, one more thing. On this network, people using this network, they are mainly recreational cyclists. They don't mind detours so much, because otherwise they would have taken a conventional route planner anyway. So in our perception, using our route planner with this recreational network, cycling a bit more to make a detour for rain isn't much of a problem for most of the users. And besides, we see that in the Netherlands most people cycle electrically these days, so distance is even less a problem than before. We used several data sources. Of course, the route network, as I mentioned, this route network needed to be corrected, because the one source we could find was topologically knew very many mismatches, sometimes 100 meters. So with our FME software, we made a topologically connecting network that allowed us to do the navigation on it. Then, of course, the main thing to have was the forecast of precipitation, and that data comes from the Meteorological Institute of the Netherlands, and they offer that data in HDF5 format. Well, we had contact with Sampo when trying to use this data, and this was we were not experienced with, had no experience with HDF5, but this was a bit of a problem, especially when using FME tooling. FME knows, like, I think more than 400 different formats which are supported. But HDF5 was unfortunately not one of them. It's a very rich format, but you can have data in many different dimensions in it. So actually one file consisted of, in this case, of 24 images of 5-minute interval data of this raster data. So it's only in one image, but it was not really usable for us in FME. So we were thinking like, shall we go to another architecture solution or not? FME had our preference because we only had 30 days time for this challenge. So we decided, no, we'll look a bit further. And then we found at Esri, there was just released a beta version of the same data coming from the KNME. So the Esri succeeded in what we thought would be a bit difficult. So we decided to have a look at the image service Esri provides of this data. Again, there came a new problem because the FME supports only image services made with ArcGIS 10 or lower or below, which an ArcGIS 10 is quite some time ago. Yep. So we couldn't use the image service and decided to make HTTP requests on this server to extract the data. Well, then about the data itself, it consists what is offered is actually a forecast of precipitation for 2 hours ahead, but split up in images of 5-minute intervals.
Yep.
Yeah. And the main challenge for us was to match those times where we expected the cyclist to be from a given starting point throughout the whole network with all possible locations where clouds could be and where rain could arrive. So in order to do this, we did a few things. We exported those images for our whole province, and we took actually all those 24 raster images for every 5 minutes, and we decided to split up the signposted route intersections from the route network in the same time lapse. So we thought, like, how far can one cycle in 5 minutes? So 5 minutes is the interval of the rain images. How far can one cycle over this network, assuming a constant speed of, say, 18 kilometers an hour? We thought that would be reasonable for prototype development. So that would be around 1,500 meters. So by splitting up the whole network in parts of 1,500 meters, we could theoretically match all the rain images to the right location, make all these 24 images overlay, and see where there were possible conflicts, so that our routing algorithm could avoid the rain. There were some problems though. Even zie hoor. Is dit de goede? Nee, de volgende moet je.
Ja,
deze hadden we net. These rain-free routes, cannot be planned unlimited. Just one quick look. Sorry. Oh, sorry. Yeah. Excuse me. Then we classified. In the beginning, we had our route network, and we were planning routes, and we had only 2 classes of weather. We had dry weather and we had wet weather. And if there were just clusters of rain, it would be easy to find a detour. But when it was raining everywhere, we found, and this was at the moment of the deadline, that the routes that came out could just as well go through the middle of a cloud where the intensity of the rain was hardest. So we thought, okay, this is no good idea because then you can get really wet. So then we decided after the deadline to classify rain into 7 classes with different intensities. And this allowed for, if it's raining everywhere, that you would still get a route with a minimum amount of rain. Then, still there were some problems. The first one, the rain is very dynamic, so it may change its course any moment, actually, every 5 minutes. And what we found is that the times that we calculated for a cyclist to be somewhere in the network might actually be different once a detour for the first rain has been made. Then our times wouldn't match anymore with the cloud's arrival because a detour is not always logical. So that, and our intention actually was like, okay, you plan a route from home and then you can just go cycling and you stay dry. But once you make an illogical detour from where you were expected to be at a certain moment, it didn't work anymore. So we thought, like, we need something else. We need a GPS trigger that knows where you are, and that based on your actual position can, at every node in the network, can recalculate like where you will be from that point onwards. So this is something we haven't implemented yet, but is very essential actually when using this app real life, because you need to recalculate your route at every network node. This has other advantages. You can, for example, then also easily take a break, or just if you get headwind, you can cycle a bit slower, and it's much more comfortable and realistic. And another thing that it solves is the forecast data is only 2 hours ahead. So if you want to cycle for more than 2 hours, there is no forecast anymore. If you have this GPS trigger, you can just have an adjusted route. There's though one disadvantage of this approach, and that's what people normally not like so much. Most people like certainty. If you start with a route planner, you're not sure how long you're going to be on your way.
No.
So it may be a very, if it's very rainy, it might become a very long trip. But we were thinking of a kind of slice or add a kind of how do you call it?
A slider. Maybe.
A slider in the app that would each user allow for itself to say, like, okay, remaining dry is worth it to me so much, like compared to the distance I need to cover. So then you can make your personal judgment, like.
Yeah, if you have a user which is wearing a very fancy hat made of thin paper, then it will and it will be allowed to ride all day to get to the destination as long as you don't get wet.
And you can also always, of course, increase your speed. So.
Yes.
Or take a break and buy a cup of coffee.
Yeah, that comes later on.
Okay, but now back to the simple prototype, in which we have not implemented all those things. Well, they're simple. It's a simple front end. We made a front end of based on GitHub, HTML, JavaScript, because we are using we use Leaflet to make a simple client. Wonderful borrowing bikes, which I used to get here, also use Leaflet, so it's omnipresent. It's very cool. We are very much into the Esri stack, so we don't often use stuff like Leaflet, but it was wonderful actually, because we had to interact with Esri RGS servers and RGS Online we needed to use the Esri version of Leaflet to consume those RESTful services. But yeah, well, the basic is still Leaflet. And we made the app itself into a bootstrap shell around it to make it scalable. Yeah, and make it look nice in a mobile phone, in which you preferably will use the app. The back end is it's RTS server, where it sends your location to. Then your location, your start point, and your end point get sent through to FME Cloud, actually, which we got to play with for this challenge. And that combines information, like Bas said, with precipitation forecast, and combines it back and sends back a route. So it's as simple as it is. Can you see these details or not? Well, then I'll just skip it, I think. Well,
yeah, it's more in detail.
It's more in detail which layers are used and which services they consume and how they work together. But it's basically the story Bas just told. So. Further possible improvements we thought of was, like Bas said, a GPS triggered reaction, which well, Bas just explained is really essential. Also, we used a simplified network because we wanted to make lots of requests and not wait too long. We could have used the OpenStreetMap network if we only had to plan one route. So it's already by design that we can use the GPS triggers. Well, what people also in the same service also available, and it's like an Inspire standard. Is head and tail winds. In the Netherlands, we don't have any mountains, so that's what was easy for making the cyclist position a bit predictable. But there's a lot of wind. So in the further versions, we would very much like to include that, because most people say, I don't mind to get a bit wet, but I would really like to plan my route if I have a lot of headwind. Why don't give me a route through a forest or into a city, and when I get back in my back, the wind will blow me away, and it will be like in a countryside, very flat land.
And Esri included the wind data in the same service already, so
yeah.
It would be actually really easy to
it's already there
to edit.
Well, the inclusion, the sliders which we just mentioned would be very good, because it's now a bit static. And the cyclist has there are all kinds of cyclists. It's a prototype, so there's only one person that can use the app at this moment, so that's easy. But if you would use it for real, then there would be a huge diversity in real in people, in users, and what they would want. So yeah, I think it's low-hanging fruit to do something with that. Inclusion of shelter places. The first route we tested went around the cloud and went into the dunes of Noord-Holland to like a different village, then came back when the rain would be away, and then went on. So huge detours in which you normally would say, well, just stop cycling, have a nice coffee, have a nice conversation, and then go on. So that was an option missing. So maybe make them more so commercially viable.
Yeah, if you like.
Yes. Yes, and of course people want to know what to call their mother and say, sorry mom, because of this strange app I'm using, I'm now arriving dry, but 2 hours late. So that's what you want. Yeah, this is what we started with, because before we really started with the challenge and found out it was more challenging than we Well, I won't get into details like course problems and stuff like that. But we thought, no, well, that is very simple. Commuting, you make it easy. You dodge some rain clouds. Of course, that's easy. But we really want to do, because we're avid cyclists, we don't mind rain. We saw an American program, Tornado Hunters, in which they go to as close as possible to tornadoes. Well, you are cycling in the Netherlands, and then there's a huge rain front, and you have a route which just takes you just next to it. So you have a majestic cloud formation, and you cycle. I'm savoring it, So that would be our ideal. So there's huge demand for this app. So, okay, Bas will show you the real app.
Yeah.
So please, no one else open the link now.
No.
Please.
No. The presentation will be shared, and you can replicate the ideas, but the prototype will taken down.
I don't know what I.
You just sold your
yeah,
soul to the devil again. No.
It sent us to Helsinki, but I instead.
It
wasn't Helsinki.
Yeah, it didn't get geolocation.
Okay, Denver, yeah. Okay, so you have no Denver here. Well, I just sent her now to Noord-Holland, where you can see all the data, all the nodes. We can just make this look a bit better, but didn't do it so far. Of course, if you zoom in, things will look better for themselves.
You see the old route?
Yeah, you see a route that I just. Let's have a look. Someone has someone has done something.
Maybe the reset button.
Yeah, we use the reset button.
All right. Yeah, and then refresh manually.
Yeah, and then
Never show your live links if it.
No, it's true.
It doesn't work for more than one person.
Yes, that's a whole different thing. I mean, that would be a boring thing to develop for more than one person. Yeah.
Let's see if this worked. Let's first see if there's some rain. Obviously, if there was some rain, you would see it right now, because the layers.
These are the layers.
These are the layers we have included. We have the nodes of the network, the paths that you can see in green, a proposed route that will come out as a result, and of course the precipitation, which turns up blue but is not yet there. There might be some in the southeast of our province.
Rain hunters. Yes. You also have to.
No.
For the future, we schedule presentations and demos based on precipitation.
Which requires another app, probably.
Yeah, of course, yes.
Well, what I will do now is just then, because there's no rain now, we will just plan a route, and this will be calculated as the shortest route, like an average route planner would do. Unfortunately.
So not very exactly.
For example, from where I live, that will be NH18. To our office. It's a route I didn't cycle so much yet, I must admit. That will be here.
Beautiful Haarlem.
Yeah.
Great.
Press go, and then at the moment I press go, you can explain actually best. The FME workbench running in FME cloud, so on an FME server installed over there, is being triggered, to do the computation, get the 24 time images, and do all the overlays with all the places where one could be expected to be at that moment.
Yeah.
And
update the proposed route service.
yeah, you can see the status in the bottom. And here it says success, so that's, in this case it only means that the server received its job.
Yes, it is.
And actually, because there's no rain, the computation goes a bit faster than if there were rain, because the interpretation of the raster values is much easier. It's all 0.
So if there is rain, how long does it take?
It may take up to 2 minutes. So, yeah, not so many people cycle 1,500 meters. And,
No, but if you use it for more than one person,
yeah.
we'd have to do some.
Look, we have a route now.
Ask some serious developers.
So, and at the moment, yeah, so you can see it's the short. Using this network is the shortest route, going from my home to my office. So I'm glad at this moment it doesn't have any details, but we actually already implemented in the FME workbench that you could see like some statistics for how much rain is on this route, how long is it, and yeah. So and these data get, if you have this GPS trigger function, get updated all the time.
Sure.
So this
That's it.
was a presentation, I think.
Thank you for your attention. Any questions?
Do you plan to update the route information, because of course there are reparations and temporary things on the road?
Well, this goes much further than our ideas of where we want to go with this.
Yeah, the assumption is that the route is the network would remain intact. It just points which point you from which signage. Yeah, so not really.
The data of the route network is not provided as a service yet, so we made a service of it ourselves, and hence as a consequence we don't have any updates. There are people in the Netherlands doing these kinds of things, so the source data is being updated all the time, so we could do that, but we have no further ambitions to be an owner of a website, of a route planner, and so on. So we developed it just for this situation.
Yeah.
For this event. Yeah.
Did you have the opportunity to use your app? Or did you stay dry?
Yes, we did.
Well, it was funny. We did some experiments. Time was very short, so we didn't have time to use it a lot. But of course, also if you might have seen the video yesterday, where we were cycling. So that was one of the moments that we were using the app, testing it, and trying to avoid the clouds. And there were some. And also one other moment that we made some recordings for the video. Then you used it, which had a funny result, because we implemented it only for our province, but Bart made the mistake to start living just outside our province. Yeah. Well,
I was traitor to the province, which provides me with salary. So
he was completely soaked with rain in the last few kilometers to us.
No, and also we found out that you see the numbers that we NH, etc. And the assumption was that the guy who made the network, was our assumption, but he made the assumption that these were unique codes. But they are, of course, not at all.
Well, the people who provide this file, they actually say they are unique. Even in the metadata says it's unique. Yes. But then you're somewhere out there testing, and
yeah.
And then it appears that our route was calculated a bit north of where we were. So this is
of course, all easily solved, but it's just, well, interesting things like this piled up on each other.
But it's not so easily corrected because these signs are out there, you know, they're signposted. So if they're really not unique, the signposts need to be changed as well.
Yeah.
So maybe you wouldn't find out without an app.
We'll tell them.
Yeah.
Right.
No more further questions?
Maybe just one quick question. Can you comment a bit on your personal experience in addressing this challenge? So you were given some data sets, but then what was the hardest step? Was to actually find other data sets in addition to those that were provided you?
Because we were provided data sets from the Meteorological Institute in Finland.
So then, for example, you had to look for the cycleways?
No, the cycle path was quite easy to find.
But so did you have? I mean, so
matching the times.
What was the actual challenge?
For me, it was everyone worked on different parts, and actually, most of the results only came together in the end. Was we discussed with Sampo in some time. But for me, the most difficult part was matching of the times. Though, for this whole network, for every 1,500 meter stretch on every green line, we needed to know from any given starting point that a user would select where one would be. And to match that with the times of the rain, theoretically this should succeed, but well, putting it into practice, we had for many occasions we had mismatches, and we had to fine-tune our computations to get sensible results. So this was a difficult step.
Yeah.
Yeah, that was
It was mainly fun and having a plan A, and then having a plan B, and then having a plan C. And in the end, because we discovered some errors all along the way, we would have liked a team member which was just testing. Now it was, okay, they did my thing, you did your thing, we put it together, we think it looks fine, and then, oh no, the route's completely wrong on the water. But, well.
You said the whole development took 1 month, you said?
Well, yeah, and then, but during that month, Wednesday evening, and we didn't work on it full time first.
The first 2 weeks we didn't do so much. We only were together a few Wednesday evenings, indeed, after office hours.
Yes.
Till the office closed at 8 o'clock, so we only... but the last couple of weeks we spent each in our homes quite some time in getting it.
Children are asleep. that goes to his computer.
It's impressive, in my opinion, taking into account so little time you have.
Yeah. No, but the tools which are out there, I mean, Leaflet is very good and easy, so that helps a lot.
It takes time.
Yeah.
Yes. Yeah.
Yeah.
Okay.
Thank you very much.